Okay, we had better energy on this side because they were standing up. So let's try it 2 more times. I think the 3rd time's going to be the charm here. All right, 3, 2, 1. Woo! All right, I'm not hearing any sound. It's just me making weird noises. Is the microphone working? Can you hear me? Yeah. Okay, great. All right, this is the last one. Last one, best one, is what my trainer says. All right, sounds, action, standing up, ready? Woo! All right, that was the best wave and only wave I've ever seen at a tech conference. So I think that's a really good way of kicking things off. So I am here to talk a little bit about what is new in Angular. How many people here know what Angular is? Okay, that's woo from me. How many people have written Angular before? Okay, those are great numbers as well. What was that? What?
JS Angular or TypeScript Angular?
If you want to talk about the JavaScript version that was deprecated back in 2014, that is not this talk. This is about the Angular that the team has been working on for more than a decade now, which is kind of exciting. We're talking about Angular. So TypeScript version, which is really, really good, which hopefully throughout this presentation you will end up seeing. There's been a lot of AI talk, so I thought I'd throw a little AI slide here. But instead of putting anything in the prompt, I'm going to put in the DevTools. Look what we see here. NG version, the Gemini app. You said I was mic'd up, and you were wrong. My apologies. Should we redo the woos? Or I think we're going to be good. What's that? My name is not Mike. I'm not mic'd up. Sorry. All right, so instead of entering a prompt here on Gemini, I'm actually opening the DevTools, and I'm seeing this is an Angular app. Isn't that exciting? I think this is really interesting because AI is empowering a lot of new experiences, right? It's empowering us to do things that we could never do before. But as developers, as engineers, when we want to take advantage of this, there's one layer which is just using prompts to make us better, right? Copilot, automatically prompting based on the code that I'm using. But if you want to ever build a tool on top of this AI technology and actually ship it to the world, you're likely going to need some sort of user experience. And obviously, we've got some great mobile platforms, but the web is still alive and well. Millions of users, billions of users, like Chrome is still a thing, I promise. And if you look, the Angular logo and the Gemini logo, kind of similar. Ooh, who knows? So my name is Stephen Fluin. Images aren't, OK, check this out. Oh, there it goes. All right, it was loading on my screen, but not the remote screen. I've never seen that before. So my name is Stephen Fluin. I am an Angular GDE. I also used to be on the Angular team at Google. So I was there for about 5 years. I led developer relations. And so my job was really all about helping people stay up to date on the latest. I left the team, but I never left the Angular community, because I think this is a really great tech. And everywhere I go when I'm building applications, I'm bringing with me the best sorts of technology that I can find. If you're looking for me, I've started, instead of listing all the social media platforms, I'm just going to write like a little social media icon, because I think it's getting a little ridiculous. I don't know about anyone else. But I am excited. Can you tell? I think that the tools that we use as developers and engineers are some of the most important things because they have a multiplying factor. Everything that you do to make yourself better ends up making your users better, ends up making other developers better, and that benefits society, which is effectively why I care about technology. And so I have this personal life philosophy that I call better life and work product through tooling. If we use the right tools in the right way, we're going to make better things at work, and those things are going to help each other, and we're going to help humanity, and you're going to live a better life. That's the kind of the assumption that I have behind technology. It's a little bit hopeful. Hopefully, we are not in some sort of dystopia in a couple of years, but I'm very optimistic. So throughout this talk, I hope 2 things. One, that you give these new cool technologies, these new techniques a try within Angular. And second, I really want you to see the future and try and see what is it going to look like to be building these sorts of applications. How easy could this be? What capabilities should we be taking advantage of and giving to the world? So I'm going to go through this in 3 sections. First, I want to just update everyone a little bit on the ecosystem. Second, I'm going to talk about some of the best practices that exist now in the Angular ecosystem. And then last, we'll talk about performance and what that actually means in a couple different senses. So we're going to start off talking a little bit about the ecosystem. And there's an important date in web development. Does anybody remember December 5th, way back then? 2 days ago? Why was this day special? React 19, hooray! React 19 came out. See, it was a great day. Everybody remembers where they were. It's a heartwarming family story. But if you remember even a little earlier, Angular 19 also came out. I don't know. Angular 19 came out before React 19. Does that mean anything? I mean, version numbers mean something. I don't necessarily know that they mean better, because otherwise Windows 2000 would still be the best Windows of all time. What I've actually seen in the ecosystem, I think it's important to acknowledge, is that React has been this really important part of the ecosystem for a long time, but it's actually evolved. Most teams no longer just rely on React. When I hear a team talking about what sort of tech stack they're using, they don't say React, they say Next. Because what happens is React is just a library, right? And so if you're building real applications and shipping them to the world, you need more than that. You need things like what Next provides, where you're providing a full framework that's not only taking care of the client-side rendering, of like how do I push pixels to the screen, but then also how do I build that? How do I pre-render it? How do I hydrate? All those other things that Next.js has become really, really well known for, and why I think Vercel has been really like killing it for the last few years as a hosting provider out there in the world. So like when I think about React, I think about React as being incomplete without a platform like Next. And so what we're seeing, and the reason I think this is important is because you can't just have a framework or a platform for building web applications. You need this entire infrastructure around it that acknowledges the developer experience, that acknowledges all the aspects of that developer experience, but then also things like how do we ship those applications as performantly as possible. And I think that the Angular team, if you look at them over the last couple of years, what they've been working on, they've really been taking this on as a core challenge. And so a lot of the features that we're going to see today are around developer experience and around performance. So this idea that developer experience matters. I think, does anyone here not think developer experience matters? Yeah. Well, we'll talk later. You're going to have to come to the principal's office. Developers oftentimes, when you're building, especially enterprise applications, where we end up seeing like these large monolithic applications that are being given to a user base that really doesn't have a choice in it, they often forget that user experience really matters. And this kind of sucks. And so I think anytime that the framework authors and the tooling providers can give you a better user experience, automatically that's critical. And we also have to acknowledge that machines are probably the primary audience for a lot of our tech now. Right? When you build a website, yes, you want your users. They matter a little bit. But you also have to care about the machines. Not just like the Google crawlers for the search indexes, but you want OpenAI to go crawl all of your content. Right? All of these things end up mattering. I love this chart because it goes all the way back to 0. This was how popular Angular, using the correct version in 2014, was 0 downloads because it didn't exist. But then if we fast forward to now, we're at like 4 million downloads per week. And so while a lot of people talk about React, there's a lot of good things. Many, many websites are built on it. We also see the same thing with Svelte and Vue. Like, there's a lot of really, really rich technology. I do want to point to some of the metrics that say Angular is one of the dominant platforms. People just don't talk about it as enough. They don't talk about it as much or enough. Because what ends up happening is Angular ends up being used a lot in these very enterprise situations where it's like, yeah, I'm on a team of 100 Angular developers, and we don't talk to anybody ever. We never go to a conference. We work on our little banking software, and it's great. Angular is very popular at Google and beyond. So I talked about Gemini, but also Google Cloud's built on it. The Google Home interface, if you ever like pull up your cameras with the new Google Home experience, that's an Angular application, Google Fonts. And then there's this big transition that's happening within Google where they for a long time had this internal platform called Wiz, where it was really used for performance critical applications, where what would happen was you would build an application with a bunch of little JavaScript snippets effectively with a corresponding Java snippet. So you would write code twice, one that could render on the server and then one that could bootstrap as needed. So when you loaded an application like Google Photos, it's not loading a single monolithic JavaScript bundle, it's loading each little feature that the application needs to function. So that was the architecture behind Wiz. And if you look at the structure within Google, Wiz and Angular are actually merging. They've been merging for 5 or 6 years, but this keeps getting closer and closer, and they've started to borrow features from each other, which is a really important step. And we're going to see the benefit of some of those features in the latest versions of Angular. And so if you look at the number of applications that are being used by Wiz, that's things like Google Search, which I think some people still use that. Not everybody's asking GPT for everything. Google Photos, YouTube. So there's a ton of usage where if you look forward a few years, we're not only already seeing pieces of Angular being pulled into that tech stack, those tech stacks are going to continue to unify. So it's important to remember, adoption continues to grow for Angular. It's a very successful, very popular framework that's used for these like world-scale applications and products that are being used by billions of people. And I would think that the evolution is really, really positive. One of the terms that I hear from the Angular ecosystem, if you're not spending tons of time there, is the Angular renaissance. Right? Angular for a long time was very fixed. It was trying to like make the stuff work, and then they got there, and they're like, what can we do to make it better? And now every release that they come out with, they're saying, hey, look, we just solved 6,000 thumbs up or requests on GitHub. So that's one of their metrics is like they look at the issue request and they see how many people have reacted to that issue, and if they can solve that issue in an effective manner, they're like, hey, we just got another 2,000. And so you'll see that in some of the release notes, which is kind of cool. So if you are an Angular developer, this is a little bit of a scary time because there are new best practices evolving. So the Angular team has always been committed to maintaining really, really strong backward compatibility. So you don't have to adopt any of the things I'm going to talk about. Like all the old ways still work. But what I will say is that the ecosystem has strongly and wholeheartedly adopted the new patterns. And so if you're building an application and you want to keep your skills sharp, you probably need to start shifting towards some of these new patterns. So I know Angular 19 just came out in November, so I'll be talking a little bit about 19. But this talk in general is kind of about the last year or two of these new standards and practices. Because what I find when I talk to developers is a lot of people are still using a little bit older versions, like 16, 17. Like, they're not all that different, but these big overall shifts in the way that people are building applications, these patterns, these practices, those are evolving. So the first one I want to talk about is something called standalone components. And the big shift here in 19 is they've now migrated to this new best practice, this new pattern, by default in 19. And so before, the way that they always introduce things is they start with a developer preview where it's opt-in. And then at some point, they flip it to be opt-out. And so we've just hit that point where now, if you build a new application, you train a brand new developer, they are going to use this new way of building components and not the old way. So this is what a standalone component looks like in Angular. It's relatively simple. If you notice that standalone true, that is no longer needed, right? It is implicit. It'll still work. But if you do some of the automated migrations, they will automatically remove that for you now because it is now the default in 19. Then you have got an import. So what is the code that my JavaScript, this component is going to rely on? Other components, other services, et cetera. And then all the normal things like providers. So previously, when you had a ng module, every component was belonging. It was owned by a module. And that's the thing that's not happening anymore, where components are no longer owned, which previously, that would establish the compilation context, right? So the module that a component belonged to was what determined when you wrote a subcomponent within there, how and where do I go get that? And so this was actually hard for developers because to know what something meant within a template of an Angular app, you had to go look somewhere else to see who owned that thing and then use that to determine the context. So now these components, because they're standalone, they're establishing all their own context. It is all fully compatible. So if you're interested in trying out modules or standalone modules, you still have, or standalone components, or you still have modules, you can mix and match these things just fine. You can have modules pulling in standalone components. You can have standalone components pulling in modules. And if you look across the ecosystem, right, there's now decades of libraries that are built for Angular that still work because of this commitment to backwards compatibility. But you can move all of your code to the latest and best modern best practices. You'll still might be pulling in some modules for some of your dependencies. So before, one of the things that we saw as a pattern across the ecosystem was that modules were one of these building blocks for the organization of my application. Right? So if I had lazy loading boundaries, it would be at the module level. So when the JavaScript got compiled, it would take each module, turn it into a chunk, and then you could load that chunk of JavaScript. You also saw this for shared services. So when you built a service, that service would be imported at the module level and then be provided to an entire module. The module is no longer that building block. And so what do we actually do about this? You can do whatever you want, but the most common practice that we're seeing is that people are using the router as the building block. And so this actually follows very naturally to the user experience you're trying to deliver, where the way that you split up your application based on like users clicking between pages of your app ends up being what they need to load in order to render that page in that context. And so instead of loading a module lazily, I can load a set of routes. So I can say, hey, this route is going to load a route file, and then that's going to pull in a set of modules. And then within that set of routes, I can provide all the data that is then available to any page that is loaded after that. So before, one of the things, the patterns was that you'd pull in these things called common modules. So you just have these like big building blocks, and you say, stuff them all in there. Like this a long time ago, like 2014 style was called barrels. This has definitely become an anti-pattern, where you don't want to be pulling in all these things that you might not need, because then our much smarter compilers and much smarter bundlers can't pull that apart and find the things you actually need and optimize your bundle. And so the new best practice is you pull in exactly what you need for a component. So every component needs to pull in the features of Angular it needs. So if you need an if statement, if you need a pipe, all these sorts of things, you just import those. And if you need to refer to any service, you import it. If you need to refer to any component. So this can feel a little bit long, but basically tooling now is so good that it'll just do it for you. Right? So if you write your template, you're missing something, it'll say, hey, do you want to import this? And if you import something that you don't need anymore, it'll automatically say, hey, this is an unused import. You should get rid of this. One of the new things in version 19 is the ability to be strict about this. So Angular has always been very good at trying to push all the developers to look the same. One of the things I hear from developers that use Angular is all Angular code looks the same. I switch companies, and I still feel like I'm running the exact same applications. I didn't have any ramp-up time. It's all following the same best practices. And so tools like this, where you can actually enforce at a compiler level that only standalone components are being used, can make your application better and make sure that everyone's following the same practices, even though within the platform there's actually two ways of doing things. All right, the next one is called signals. How many people have used signals in Angular before? OK, we had a lot of hands for Angular developers and no hands for signals. I'm actually kind of surprised about that. But signals have been a new primitive that is introduced within Angular that is really designed for reactivity. And we need reactivity when we're building web applications, because nothing happens synchronously. Like JavaScript is a single-threaded language. Every time you want something that a user does to do something else, you're probably going to fetch state from the internet. You're going to update state across the application. And so by having a new, better primitive for this, a simpler primitive, we can make sure that the communication across an application is performant and efficient and clear. So basically, signals give you reactivity everywhere. So it's not just a UI layer thing. And then by leveraging signals, we can actually simplify the way that the application is rendering your application. And it's a much simpler library as well. So signals are really easy to create. You basically just call the signal function, and then you give it an initial value. If anyone's used RxJS before, this is very similar to a behavior subject, but doesn't have the complexities of a behavior subject. It's relatively simple. And then anytime I want to refer to that as a value, I just call it as a function, right? So I've created count, which is a signal, and whenever I call it as a function, it's going to give me the value of that signal. The magic here is then you can update the value, you can set the value, and what will happen is a signal is like a variable, but then it knows who's listening to it. And so then it can notify exactly the parts of your application that need to know that that signal has been updated, and then re-render just those pieces. So it's a very intelligent way of tracking the dependency of content and variables and data across an application. You can also create what's called a computed signal. So this is where, hey, I don't always want count. I don't want a variable that I'm just setting. I want to actually change that variable and do something with it. So a lot of times, for example, I'll see a signal coming from a big, large data set, and then you'll have a computed signal, which is taking that large data set and filtering it. And so then, again, double count is just a signal. You refer to it as a function call in your templates and anywhere in your code. And then what will happen is anytime count changes, double count will also change. And it will notify just the components that are listening to double count that it needs to be updated. So when you use in a template, you just call it as a function. So really simple UX. And it gives you these precision updates where if you have a view that is listening to a signal, we can update that view only when it needs to. And so this kind of reactive primitive really makes future applications performant. Because in the past, we've had something called zones. So zones was the magic of Angular back in 2016 when they hit 2.0.0. Where what they did was they monkey patched, and by default, you still actually use zones. They monkey patched every asynchronous event in the browser to tell Angular that, hey, something asynchronous has happened. You should go check everything. right? Obviously, this is very inefficient. This is a bit of a problem. And what's happened is we now have async await, where async await is not monkey patchable, right? It is a native like Chrome browser feature. And so there's no way to tap into that to notice when an async event has actually happened. Usually you don't run into this because the asynchronous events that you have, or async await is usually compiled away for older browsers. But as our new browsers get better and better, we're not doing that as often. And so this kind of was a fundamental problem for zoneless, because if we can't detect when something's happened, like a timer or a request animation frames come back, then we can't update the UI and make sure the change detection is happening. But by moving everything to signals, then it's very, very easy to wrap any asynchronous event that you have, whether it's an HTTP call, fetch, async await, in a method that is now going to notify the rest of the application in all the appropriate places what is updated, and then they can re-render as needed. And you can actually do this at any level of the tree, where we don't necessarily even have to re-render a subtree. Right? If a parent component is relying on a signal, but the child components don't also rely on that signal, we only have to update the parent component. Within the last year or so, they've taken this idea of signals and they've manifested it across the platform in a bunch of different ways. So inputs can now be represented as signals. So an input is when you give data into a component. You say, hey, I've got a person card and I'm going to give them the ID of the person. Right? That ID can now be a signal, so that if you're doing virtual scrolling or whatever, you can swap those IDs out and that component will re-render as needed. You can do similarly with outputs. So if you have that person card and you hit an edit button, that can let the rest of the application know that event happened. You've got queries. So if you're actually looking at the structure of the componentry and the HTML on the page with a query, you can get all of that query as a signal now. And there's been 2 new ones introduced in 19. The first one is a linked signal, which is a little bit complicated, and I won't delve too deep into this, but I'll try and keep it simple. But effectively, there were cases where you both want a signal to be calculated based on something else, but also editable. A good example of this is, imagine a dropdown with 4 values. Previously, if you had a signal selecting one of those 4 values, that would be great. But then if you ever updated the dropdown, you've now kind of broken your signal, right? Because you're going to lose that user preference. But if you have a linked signal, you can say, hey, this is based on this dropdown, and it's user configurable. So if the user selects the 3rd item in the dropdown, and then the dropdown changes, you can select the 3rd item in the next set. And so you've got this kind of best of both worlds of being able to set a signal and have it be computed based on something else. And then the last one here, in terms of APIs that have been introduced for signals, is resource, which is actually a really, really interesting one because it's, in my mind, taking on part of what RxJS did and making it as simple and as easy as possible. So the resource API looks a little bit like this, where you'll have an input, for example, like a user ID, and now I can define a resource that is using that user ID, and it has what's called a loader. So this can be any asynchronous function you want, and it will load that data. So this could be an HTTP request, this could be a database, like a user interaction, this could be anything asynchronous. And the magic here is that not only now do I have the value as part of that signal, so it works just like a signal, like in any other context, but we also have additional state about that resource. And so you can get the value. You can ask it, do you have a value yet? Right? If you're making an HTTP call, we might not have a value. We might want to do something with that. It's got an error. Like you can see, hey, my HTTP call failed or it didn't fail. I can see if that is loading. You can actually, there's a method called reload where it will trigger a reload of that resource. It'll just re-invoke that load method. You can give it an abort signal. So you can say, hey, if this happens, give up and stop trying. Don't keep loading anymore. And then you can go and get the status of that resource as well. So you can see, is it idling, erroring, reloading, all these sorts of things. So it's like a signal on steroids that is really, really great for anything asynchronous that you need to go and fetch.
Can that be shared between components?
Yes, absolutely. Yeah, because at the end of the day, this is just a signal with extra capabilities. Yeah, the idea is that like whether it's a computed, whether it's a resource, whether it's a linked signal, all of these end up getting used identically in your templates. They end up getting used and have all those same benefits of being able to share state across an application and intelligently update only the components that need to update. One of the new ones that was very popular is the new template control flow. This is in the actual build of the platform. This was a big change because it used to be that ngIf and ngFor and all these things were like actual directives that they imported. So like theoretically they were permissionless and anyone could go build them, but no one ever did. And so what they did is they actually added it directly into like the core of the platform. And so you now have an @if, @else, @switch, all these sorts of things. And developers have in general seemed to really, really love this. So instead of having like to make a for loop where I want to make a div for every person in a database, I now make an @for loop, and then I have a div within there. So instead of like putting the for loop at the context that's then repeated and stamped out as a template, this just kind of matches your mental model for the programming a little bit better. This was really, really buried in some of the release announcements for 19, but it's one that I'm a really big fan of is now we have build declarations. And so when you run a build, so this is how the process that we take to turn all of the TypeScript that you've written into JavaScript, HTML, et cetera, that can be shipped to the browser. Excuse me. You can now define variables that end up in the JavaScript context. And so the thing that like I've had a problem with over and over and over throughout my time is when I do a build, I want to track that build number somewhere in the application so I can show it as an error message, show it in the footer, whatever. I want to version my application in a way that's presentable. Historically, I would do that in code by changing like an environments file. But then you have this like weird oddity of like I have to make a commit that changes the commit that shows the build. And so what this does is it allows you to do that as a build time parameter. So you can have a single version of your application that now every time we build, we can just print the SHA, for example. We can give that to the application as a variable, then you can print it in the right places. You can use that in your error messages. You can notify things like Sentry or Bugsnag or whatever integration you're doing to track production level errors. And so there's a lot of uses for this that I think we haven't even started to scratch the surface. And I think this is super useful. All right, so we talked about the developer experience. Now we're going to talk about performance, because performance is something it's never going to be fixed all in one fell swoop. You have to just work at it and work at it and work at it. This is me doing a handstand. It took me 2 years, but now I can do a handstand. It's taken Angular a long time to think about things like server-side rendering and hydration, things like that. But every year every 6 months, they take a really good step forward. And I think people are really, really happy with where they are today. So the main way that we talk about performance, I mean, in general, there's two types of performance. One is what does the user perceive? And then second is like what is actually happening behind the scenes. And so ideally, every application would load instantly, and then would never have any loading or any delays. And one of the ways that we achieve that is by making the browser do less. Do less from a network standpoint, so we need to load less JavaScript, do less CPU, loading less content. Like historically, like 10 years ago, if you had a giant monolithic application, I've seen applications as big as like 15, 16 megabytes of JavaScript, which the browser loads and starts rendering everything all at once. Right? This was great on our super high-powered developer engineer machines, but this sucked for users. And so we now have better techniques to address this. And server-side rendering and pre-rendering are some of those. So you might want to SSR or server-side render, which is create finished HTML on the server and then deliver that to the user. Pre-rendering is the same, but instead of generating it on the fly in response to a request, you render it at build time. But it gives you improved performance, better accessibility, because when you generate that HTML and then ship it to the browser, then you don't need special tools to like figure out when to parse the page and things like that. So that improves crawlability as well. Improve core web vitals, so things like largest contentful paint, measure how much the HTML of your page changes while it loads. Improve search engine optimization, because obviously there's crawlers that don't know how to do this. One of my favorite crawlers that I think a lot of people forget about is like the Blue Sky, Twitter, Facebook share button. When you want to share a page of your application, that thing doesn't know how to run JavaScript. Google Search can run JavaScript, but Twitter doesn't. They don't know how. And so like by pre-rendering or server-side rendering your page in some way, they can get an intelligent preview that is valuable. And just generally happier users, right? Because I think oftentimes we forget about the user, but every second that you make a user wait, you're making them hate you more. They're going to make you leave the page. You're not going to be successful at achieving the goals that you've got for yourself. And so let's imagine we build an application, we completely server-side render it, and then we ship it to the browser, and they click on a button and nothing happens. That would suck. So we need to find some way to reconcile this world of HTML that you're sending down to the browser and the execution context of your application so that it can be vibrant and alive. And the way that we do this is called hydration, where you take the HTML that's on the page and you match it up to conceptual primitives like components, rendering, context, all those sorts of things, so that when a user clicks a button, it knows what button was clicked, it knows how to transform the HTML because it has all the understanding of the application. So we want the best of both worlds, right? We want a server-side render, so everything's fast and instant, but then we want the full functionality of an application, and as a developer, I want that to be really easy. So lazy loading, like doing this, like loading the right parts of your application at the right time, is really, really hard. So I'm going to imagine a application where I've got this component called recommended movies, and I want to lazy load that, right? It sounds like a normal thing, right? Like I'm going to load my content, and then I want to recommend some more, but I don't want to block the whole page to go fetch additional recommendations. But how do we do that? This seems trivial at first, but you have to think about a lot of different things. Loading status. What if it doesn't work? Like, what do I show the user while it's loading? What if it fails? What if the internet went out, right? They're on their phone, they're on a subway, internet went out, what do I do? When do I want to load that? Do I want to load that immediately when the page loads? Do I want to give the user a few seconds? Do I want to wait till their network is not there? Do I want to wait till they click on something? We call or when they scroll into the viewport. We call those intersection observers. And then what do we do about the children? What do we do about all those like refs that we have? And so there is a new primitive that is available. It's called the defer primitive. So this follows that same new control flow syntax that we talked about for like for and if. And effectively what defer does is you just wrap whatever HTML you want in a defer block, and it will become lazy loaded. It will say, OK, I don't need this to load the page. I can load it later. And so then the JavaScript bundler and the compiler know that I can separate that component into a separate chunk. So I don't need all that HTML. I don't need all that JavaScript to start. And you can throw on a loading tag and render whatever you want while that content's loading. You can throw on an error tag. So if that chunk fails to load or fails to be rendered for some reason, we can render that. And then you can even do more intelligent things. You can parameterize your defer call based on what happens on the page. So imagine that we have that recommended section, but we only fetch that when the user scrolls to that portion of the page. Right? This is trivial. You just say, whenever this target is in the viewport, we're going to load that. You can also say, you can combine these. You can say, prefetch it if the browser's idle, but if the user scrolls there and the page is not idle yet, let's fetch it anyway. And then you can kind of make this much, much more complicated because you can now combine all these different capabilities, right? You've got the defer, the viewport, prefetching, all these sorts of things. And so there's a bunch of different ways that you can do this. You can defer just in general. You've got the loading error placeholder. But then you can also trigger on idle, on immediate, on timer. So you could say, hey, load this after 15 seconds. I'm actually doing that on one of my docs pages that I've been maintaining, which is the marketing and sales team wants us to pop up one of those live chat windows. And I pulled it up. Our page was about 400 KB of like HTML and like renders, like fully in, 400 KB. And the intercom pop-up they wanted was 3 megabytes. And I was like, I do not want to block the rendering of my docs pages to load 3 megabytes. Like, it's probably fine, but it's going to negatively affect user experience no matter what sort of device they have. And so I just threw it on a 15-second timer. On viewport, so only when the user can see it. On interaction, so often I do this with search. So for example, I'll have a search component, and I won't load the search backend or Algolia search. Algolia search is about 1.2 megabytes. I won't load those experiences until the user clicks and starts interacting. Also on hover, which is another kind of like, hey, I think they're about to click. And then one of the new things in V19 is we now have incremental hydration. It used to be that when we wanted to hydrate the page from a server-side rendered version, we had to hydrate the entire thing, every component, every layer. But now the Angular application can be intelligent and actually figure out which parts of the application need to be hydrated. So this is going to look and sound a lot like Wiz, where you only load the bits of JavaScript that you need to do any interaction. And so this is kind of that merger of those two pieces of technology manifesting so that we can be much more intelligent. Because you might have a giant monolithic application, but if we don't need all of it to do one user interaction, I don't know, to comment on a post or to rank something, let's not load all of that JavaScript. There's so much more in version 19 that I don't really have time to get into. We've got, so I'll just do a really, really high-level summary of some of these things. So you've got zoneless on the server. So I've talked about how signals can like intelligently notify different parts of the application. And so the Angular team is really building towards a future where they get rid of zones entirely. But obviously, a lot of applications rely on it, right? We rely on that monkey patching and how that works. But you can now opt into zoneless, and then you can opt into zoneless on server-side render. So that's one of the big things. They'll automatically replay events. So let's say you're doing one of these hydration solutions. If the user clicks or does something, while that piece of the application is loading, it will replay any event. So the user's interaction won't get lost. I was bit by this several times when I was trying to make my search, my Algolia load properly, where like the user would click really fast, type in a search, and then Algolia would load and just destroy it all. So this fixes it. They've got hot module reloading. It's not HRM, it's HMR, hot module reloading for styles. So today, if you're building an Angular application, you're in the editor, all of this will just update. If you change one of the styles, they don't have to reload the entire application. They'll just reload just the styles. They've got experimental support for that with components. So again, this is that faster, better developer experience. So as you're building, you don't have to wait for an entire rebuild, even if you have this giant monolithic, poorly architected application. One of the top requested features of all time, although we should talk about it, whether that's a good architectural idea, but you can now, there's an @let primitive directly within the templates. So you can just create a random variable whenever you want and just say, hey, here's a new variable at this scope of my component. And then there's a lot of work going on the security side of things for the content security policy, which most of us usually don't have to think about, but it effectively just makes explicit declarations about what JavaScript, CSS, et cetera, your page should be loading, so that if someone's trying to inject scripts, it just won't work. So that was on the Angular kind of core CLI side of things. There's also the Angular Material project, which is just this really great default styling component library that a lot of people use, as well as the CDK, or the component dev kit, that a lot of component libraries built on top of Angular actually use as an underlying primitive. They're unstyled. But they've simplified theming, so it's easier to specify, hey, I want this color for this. Here's like a bunch of Sass that's going to style the page. You've also have 2D drag and drop. So if you ever do drag and drop, there's a library for that, but it used to be only in lists that go in a direction, like horizontal or vertical, but now you can do two-dimensional. You've got draggable tabs, so there's a tab component, but now those tags can be reordered by a user. And they added a time picker component. So what I love about these is you don't need any of these to be a successful framework. But by having, the team is really focusing on what do developers care about, what are the things that they wish that they had, and now chasing after those one by one by one. So a lot of you are here. You've used Angular before. You've never used signals before. You've never used standalone components. This sounds really scary, right? The whole ecosystem, the whole world has changed under my feet. What is this, Angular 3? This is terrible. Fortunately, the team has prioritized automatic migrations. So each of these is a script or a command that you run effectively using the CLI. They will automatically migrate all of your code from the old best practice to the new best practice. So ng-generate Angular/core standalone, that will go and take any component or any subtree of your application and rewrite all the modules into standalone components. It's also capable of fixing the entire bootstrap of your application. You've got the control flow. We'll automatically fix ng-if, ng-for, all those things into the new standard if you want. And you can do it, again, for your entire application. You can do it for any subtree of your application. If you as a team have decided, hey, yeah, we should probably switch to these. This is where the ecosystem is going. You can just try it, and it will just kind of work automatically. You've got this for injector. So like instead of using inject at a constructor, you can actually, there's a new inject keyword you can use. Lazy loading. So it'll automatically lazy load your routes using the new kind of router standalone component mechanism. You've got signal for inputs, signal queries, signal for outputs. And then there's an entirely new application builder based on like Vite that's much faster, much better. Again, this is the Angular team trying to make it really easy for all the applications in the ecosystem to stay up to date and to move forward together. And part of the reason they do this is because they have to do this for Google anyway. So there's like hundreds of thousands of test suites from applications built all across Google that rely on Angular. And so anytime they deploy a breaking change to Angular, it breaks all those applications. And so they automatically have to fix it. And so rather than going one by one, they build these code mods, these transformations that automatically fix it for everybody. Because they have to do it for Google, why not just fix the entire ecosystem as well, which is a mentality that I really love. And I wish basically all applications out there had to do this. And actually, I want to show one more thing, which is command lines are scary to some people. I know a lot of .NET developers that don't like command lines. Do you like command lines? OK, great. So what they're doing is they're adding this into all of the language services. So if you're in VS Code and you have one of these old-timey inputs, you can now just click on this little light bulb and say convert it to a signal. Can do it for you. So they're trying to not only surface these as tools that you can run on any scope of your application, but then also hey, let's just surface it in the UI. Hey, you did it the old way. Do you want us to fix it for you? Which I think is really, really cool. All right, so hopefully everyone here has seen that Angular is easier than ever. Everything just keeps getting better and better, and that the future is really bright. That is going to be it for me. Thank you so much. Do we want to do questions? Do we have time?
Well, we could do a question.
One question.
Make it count.
Press the button so everyone can hear you.
Yeah, so I have a quick question for the deferred keyword.
Yeah.
Are you actually like rewriting or forking the JIT compiler for JavaScript, or is that like just a framework on top of that?
So there is no JIT compiler anymore, just in time. Everything is ahead of time compiled now. But this is a native part of the framework, so it knows that the components, like normally you have template code that runs, right? So you've got this Ivy runtime where it says like, hey, this component needs to be here. When you wrap it in a defer block, instead of saying this component needs to be here, it says, I need to go get this from somewhere, and then render it. Awesome. Well, thank you all so much. We'll go on to the next talk.